veranda that's coming over one of our windows, and essentially it's positioned so that in summer we get shade on that window, and in winter it actually lets the sunlight in. So I think the position of the building is also that we get a little bit more of that sunlight in the winter and a little bit less in the summer. Again, we've got the low louver windows in here as well. Being north facing, we often find that this side of the room is a little bit warmer than the south side, than the south facing side of the room, and we actually do sometimes have to use the blinds and things like that. Windows are double glazed, so they're not tinted. They look a little bit tinted sometimes because of the stickers that are on them. Can you all see what animal stickers it's displaying? A frog. Did anyone not see a frog in the stickers? Well, when you see it in colour on the banner, sometimes it really confuses people. It just looks like dots and dashes.
Boomerangs and dots.
Sorry?
Boomerangs and dots.
Boomerangs and dots, exactly. Well, all of those dots and boomerangs and things down the bottom of the banner there are basically what made up the frog. But I'll talk about the frog a little bit later on when we're outside. So we do have double glazed windows, so that helps to reduce the heat transfer from inside to out in winter and from outside to in summer. So basically it is an insulator for the building. The other thing that's helping with insulation is the blinds. Obviously we want to sometimes be able to make it dark, but we've got black on the blinds on the inside, so we can make it dark and we can reduce the light that's coming in if it is too bright. If you look at the very top of the roll, you can see what colour the blinds are on the outside. Why would that be? Yeah, so it reflects the light, so it actually helps to keep it cooler. Most of the walls on the building, and we'll see this when we go outside, are white, and as we said, the roof is black. If we're looking in this room as well, you may see, depending on where you're standing, the vents that are above the panels. Those panels that are hanging down are not to do with energy efficiency, they're to do with reducing echo, they're acoustic panels. So that's what they are, but they're positioned under the vents so that when the air comes through, what's going to happen to it?
It's going to spread out.
Yeah, so it helps to disperse the warm air that comes through. Now, I didn't actually ask you why we wanted to have a hot box display for the temperature as well as the inside temperature. Why would that be a good thing?
To see how much heat is coming out of it, or
to see how much warmer it is than the inside temperature.
Yeah, it's probably more to do with that. If you're in here on a cooler day, you think you'd like to put some warm air down from the hot box, and it's actually cooler, it's not very useful. Now, the hot box is really good if you've got a nice sunny day or you've had some time to actually warm up the hot box. What would be the backup plan?
heaters?
Yeah.
Those gas
So
heaters that are around?
yeah, they're natural gas heaters, which is a little bit better than the LPG or an electricity. They're still burning fossil fuels, but we try to make the differences where we can. Now, the other thing about these heaters is, again, like our lights, we don't have quite as many heater switches as for our lights, but they will be in sort of two halves for a room. So if we're only using that half of the room, if we're having a meeting at that table, for example, we wouldn't be turning on these ones. If we have a normal teaching day where we have students coming in winter, do you want to guess how long we'd have the heater? So if you walk past a brick building on a hot day, can you feel the heat coming off it? Or even the concrete sometimes, if it's a really hot day, you can feel the heat coming up. Yeah. That's the sort of thing, it's not quite that extreme here, but the idea is having what we call a high thermal mass with all that concrete is going to absorb that heat and slowly re-release it. So the sunshine that shines in, the heaters themselves, I'm not quite sure why they're not facing the bricks if that's the idea of them. The other thing about these heaters is that they're patio heaters, so that rather than trying to heat all the air in this space, they're trying to heat the objects, such as the concrete. And that's what makes them quite efficient. Anything else? We still have all of these louver windows at the bottom here, and you'll notice that they're actually going to capture breeze from the wetland as well. So if the breeze actually comes across the water, it cools down before it gets here. Now, if we were to open up these windows, we also have some high louver windows at the top here, if you look up here above the green roof thing. Now, we can mechanically open those, I just need to press a button when they open up. And what basically happens is the shape of this wall here drags this air that's coming in from outside and is cooled down up the wall and allows the hot air to escape out the top. So that's the design of the wall, and it's quite effective in cooling the room down. The other thing about the shape of this wall is not the shape, but the design of it, we've got this inside section and we've got the colour bond on the outside, and there's a gap between them. It's called a trompole, because what happens is the same as the air would come up through these windows, it actually goes up through an opening. There's mesh at the bottom of the two layers of the wall, comes up through the inside of it, and again is released out the top through a damper. So that's effectively cooling the whole room down when we have that sort of, or that's happening anyway. The damper just closes when it's raining, but we can open these up and it cools the room down quite significantly, and you can feel quite a breeze coming through. So that's a unique feature of this room, but it is one of the ESD features.
The top row are photovoltaic cells. So what they basically are is a couple of layers of silicon with some impurities in them. When the sun shines on them, basically activates a chemical reaction between the impurities in the silicon, and they essentially jump up an energy level, and we harness that energy. So we're basically harnessing the energy from a chemical reaction there. We don't use that directly here because we don't have a generator. We send it back to the electricity company and essentially get a credit on our bill. So that's essentially how those ones work. They can contribute up to about 10% of our electricity, so they're essentially a demonstration to looking at rather than actually contributing an awful lot of our power. The bottom four though we do use directly here. Any guesses? Yeah, so the hot water. So they actually work a little bit differently. They basically have thermoreceptors in them, and they heat up the water through pipes, and the water moves through the heated up area and through the building. So it's basically